You have seen the images. They have been circulating on the internet for months, popping up on your social media feeds, appearing in the headlines of science websites, and sparking debates in online forums. They are tiny, red, and impossibly distant. They look like faint smudged dots of light, barely distinguishable from the background noise of the cosmos. But these little red dots, as they have come to be known, are not just any dots. They are the ghosts of the early universe, relics from a time when the cosmos was barely 5% of its current age. And for the past 4 years, since the James Webb Space Telescope first spotted them in 2022, they have been driving astronomers absolutely crazy. These little red dots were a puzzle. They were too bright, too compact, and too massive for galaxies that existed just 500 to 700 million years after the Big Bang. If their brightness came from ordinary stars, those stars would have to be packed together at densities that defied the laws of physics. The night sky inside such a galaxy would be dazzlingly bright, a continuous blaze of light with no darkness anywhere. Traditional models of galaxy formation could not explain them. So astronomers did what astronomers always do when they encounter something they cannot explain. They gave them a nickname. They called them universe breakers. And they pushed for deeper observations. Now, in the summer of 2026, we finally have an answer. And it is so bizarre, so unexpected, so utterly mind-bending that it has forced us to rewrite the early history of the cosmos. Those little red dots are not galaxies at all. They are something far stranger. They are black hole stars. They are single supermassive black holes, each one cocooned inside a glowing shell of gas so thick and so bright that it perfectly mimics the atmosphere of a giant star. We have discovered a new class of cosmic object, one that bridges the gap between the darkest objects in the universe and the brightest. And in doing so, we have unlocked one of the deepest mysteries in all of astrophysics. How did the supermassive black holes at the centers of galaxies get so big, so fast? Let me take you back to the beginning. The story of the little red dots starts with the launch of the James Webb Space Telescope, the most powerful space observatory ever built. Webb was designed to look deep into the infrared, to see the light from the first galaxies that formed after the Big Bang. And it did not disappoint. Almost immediately, it started sending back images of the early universe that were sharper and more detailed than anything we had ever seen. But mixed in with the images of distant galaxies were these strange, compact, bright red objects. They were tiny, much smaller than the galaxies around them. They were incredibly bright, far brighter than they had any right to be, and they were red, which meant their light had been stretched by the expansion of the universe, indicating they were incredibly distant, dating back to the first billion years of cosmic history. For years, astronomers debated what these little red dots could be. Some thought they were extremely dense galaxies, packed with stars that were forming at an impossibly rapid rate. Others thought they were active galactic nuclei, supermassive black holes at the centers of galaxies that were actively consuming matter and emitting huge amounts of energy. But neither explanation quite fit the data. The galaxies were too compact. The black holes were too bright. Something was missing. Then, in 2024, an international team of astronomers led by Anna de Graaf of the Max Planck Institute for Astronomy decided to take a closer look. They pointed Webb at one of these little red dots, a particularly interesting specimen they named the Cliff, and they spent about 60 hours of telescope time breaking down its light by wavelength. This is spectroscopy, the technique that allows astronomers to determine what an object is made of and how it is moving. What they found was astonishing. The Cliff, which is approximately 11.9 billion light-years from Earth, meaning its light began traveling long before our own planet even existed, had a spectrum that was unlike anything they had ever seen. There was a dramatic drop in brightness at a specific wavelength, a signature called a Balmer break. This happens when hydrogen gas absorbs certain frequencies of light. But the Cliff's Balmer break was twice as strong as any known stellar model could produce. It was so strong that it forced the team to abandon their traditional assumptions. This was not a galaxy of ordinary stars. This was something else entirely. The explanation they settled on completely flips the script on how we look at space. The cliff is not a galaxy full of separate stars. It is a single supermassive black hole consuming surrounding matter at a rapid pace. This rapid feeding has trapped the black hole in a dense, glowing sphere of hydrogen gas. Compressed and heated by the energy released as matter falls inward, this gas shell is so thick and so bright that it looks like a stellar atmosphere from a distance. Joel Leja, an associate professor of astrophysics at Penn State and a co-author on the paper, explained that the team looked at enough red dots until they found one with too much atmosphere for typical stars to explain. What they found was a black hole wrapped in an atmosphere so dense that it mimicked the surface of a star. They coined the term black hole stars to describe these objects. Not stars in the conventional sense, but black holes wrapped in dense atmospheric shells that mimic them. And then, in June of 2026, the story got even more interesting. A team of astronomers led by Vasily Kokorev at the University of Texas at Austin used the power of Webb combined with a natural telescope, a gravitational lens that magnified the light from a distant object to obtain the deepest spectrum to date of a little red dot. This object, referred to as glimpse-17775, revealed more than 40 spectral lines, each one a piece of evidence that converged to support the black hole star scenario. The little red dots, it was now clear, were black holes enshrouded by cocoons of hot, dense gas. The puzzle was finally coming together. Now, let us pause for a moment and appreciate the sheer scale of what we are talking about. A black hole star is not a star in the traditional sense. It is not powered by nuclear fusion in its core. It is powered by gravity. Matter falls into the black hole, and as it does, it releases an enormous amount of energy. That energy heats the surrounding gas, creating a glowing shell that can outshine an entire galaxy of ordinary stars. The black hole at the center of a black hole star is not a small thing. It is a supermassive black hole, with a mass that can be millions or even billions of times the mass of our Sun. And it is growing, consuming matter at an astonishing rate. This is not a slow, steady process. This is a feeding frenzy. And that is where the mystery deepens. Modern galaxies routinely harbor black holes at their centers that weigh billions of times the weight of our Sun. How they grew to that size remains one of cosmology's most stubborn, unresolved questions. They started from much smaller seeds in the early universe. But the universe has not been around long enough for steady, slow feeding to explain their current scale. A black hole consuming matter at the extreme rates implied by the cliff would grow extremely fast. This turbocharged growth explains how these cosmic seeds grew so large in such a short window of time. The black hole star model fits the data perfectly. It explains the brightness, the compactness, the spectral lines, and the puzzling mass of these early black holes. Leja noted that these black hole stars might represent the very first phase of formation for modern giant black holes. Let me try to paint a picture of what a black hole star would actually look like. Imagine a sphere of gas, thousands of times larger than our solar system, glowing with the light of a billion suns. At the center of this sphere is a black hole, an invisible point of infinite density, consuming matter at a rate that would make any normal star blush. The gas is falling inward, spiraling toward the black hole, heating up as it goes. The outer layers of the gas are cool, relatively speaking, emitting light in the infrared, which is why these objects appear red. The inner layers are hot, emitting light in the ultraviolet and X-ray. The whole thing is a chaotic, violent, beautiful mess, a cosmic blender that is churning matter into energy at an unprecedented rate. And from a distance, billions of light years away, it looks like a single, tiny red dot. This discovery is not just about understanding the past, it is about understanding the present and the future. The supermassive black holes at the centers of galaxies are not just passive objects. They shape the evolution of their host galaxies. They regulate star formation. They influence the distribution of matter. They are, in many ways, the engines that drive the universe. Understanding how they formed is essential to understanding how galaxies like our own Milky Way came to be, and the black hole stars provide a crucial piece of that puzzle. They show us that the first black holes did not grow slowly over billions of years. They grew rapidly, in a frenzy of consumption, hidden inside cocoons of gas that made them look like stars. Now, here is the part that Richard Feynman would have loved. Feynman was a man who was obsessed with the idea of what is the simplest explanation. He believed that the universe, at its core, was elegant and understandable, and the black hole star discovery is a perfect example of that elegance. For years, astronomers were confused by the little red dots. They proposed complex models of exotic galaxies, of impossible star formation rates, of unknown physics. But the simplest explanation, the one that fit all the data, was the one that was hiding in plain sight. The little red dots were not galaxies. They were black holes. And once you saw that, everything else fell into place. But there is an even deeper lesson here. The black hole star discovery is a reminder that the universe is full of surprises. We think we understand the cosmos. We have built models, written equations, and made predictions. But every time we build a better telescope, every time we look a little deeper, we find something that we did not expect. We find universe breakers. We find objects that defy our categories and challenge our assumptions. And that is the most exciting thing about science. It is not about confirming what we already know. It is about discovering what we did not know. This is the spirit of Feynman's Curiosity Lab. We do not just learn about the universe, we explore it. We ask the big questions, we build the instruments, we look at the data. And when we find something that does not make sense, we do not sweep it under the rug. We lean in. We dig deeper. We ask, what is this thing? And sometimes we discover something that changes everything. So the next time you look up at the night sky, think about the little red dots. Think about the black hole stars, hidden in the distant past, glowing with the light of 1 billion suns. Think about the supermassive black holes at the centers of galaxies, growing from tiny seeds into cosmic giants. Think about the James Webb Space Telescope, peering across 11.9 billion light-years of space and time, capturing the light that has been traveling since before our planet existed. And think about the fact that we are living in a golden age of discovery. We are the generation that is rewriting the history of the universe. We are the generation that is discovering black hole stars. We are the generation that is asking the questions that our ancestors could only dream of. This is Feynman's Curiosity Lab. Stay curious, keep asking why, and never stop looking up. The universe is full of mysteries, but it is also full of answers. And every time we find one, we realize that there are a dozen more waiting to be discovered. The little red dots have given us a glimpse into the birth of the cosmos. What will we find next? The only way to know is to keep looking.